in Southeast Asia differ dramatically from those that we see in Western Asia. And it's all related to the kinds of plants that were natural to those areas. And again, if you go back and look at what Jared Diamond said, trying to document the distribution of these wild potential domesticates, is that the two areas that had most to offer are the two areas where we see this occurring early on. There are also two of the areas where in the latter part of the Upper Paleolithic and the Mesolithic period, we start to see population increases on pretty significant scale. So there's domestication doesn't just happen because there are available plants and animals around. It happens because there's a need. People are expanding to the sort of the natural carrying capacity of their environments, and they either have to restrict their populations, which most societies don't like to do, or they have to, especially in these earlier time periods, the most common, probably the most common type of population restriction would be infanticide. They either have to do that or they have to figure out other ways of getting food. And so domestication is that. So if we look at early Southeast Asian domesticates, the big one here, the huge one here is rice. And it's probably the most widely consumed plant on our planet. It's also one of the weirder plants because it grows, as you'll see, it grows in water. But you also have in the northern part of China, you have two millets that were domesticated: Foxtail Millet, root corn millet. A lot of times today, these millets are being used to feed domestic stock, but they're certainly fully edible and consumable. And these were two big contributions. In the south, so there's a northern and a southern area for domestication in Southeast Asia or East Asia. In the south, you have another plant called the water caltrop, and then a foxnut piece, again, grow in very water saturated conditions. And so the pattern of growing crops in the south and the north differ considerably. The north is in a lot of ways has more similarities to what's going on in Western Asia, but the southeastern part is the big difference here. If we look at the animals, I'm just going to pull all these up. Oops, sorry, I went too far. The major animals that are domesticated include cattle and the water buffalo, pigs, of course, and we now know there's been recent evidence to show, and there's quite a bit of evidence now to show that pigs were domesticated independently all over the place. It was easy to domesticate pigs. They eat the same kinds of food that humans eat, so the leftover, the scraps, the feed to the pigs. They're kind of the perfect size, perfect breeding patterns. They can be aggressive, but that is spread out. So pigs are very, very probably the most commonly domesticated animal out there. Not necessarily the most productive, but the most domesticated. And the other thing that you see in Southeast Asia are domestication chickens. That's a plant, sort of an animal, but a bird, one of the few birds that was domesticated. And it was widely distributed, as we'll see. And it plays a big role in pigs and chickens play a big role in the spread in Polynesia. We'll talk about here in a little bit. If we look at rice, just to show you, this is just a rice plant, and you can see you have the root system here. Here's the topsoil. It gets planted here, and it grows in 6 to 8 inches or so of water. It requires an enormous amount of water. Because of that, the areas where you can grow rice is limited. There's a lot of rice grown here in Texas, It's virtually all, as far as I know, grown very close to the coast, where there's a hell of a lot more water. You don't see many rice farmers up in the panhandle, let me put it that way. That's not something, they're growing other plants like cotton that take a lot of water, and that's going to not be possible down the run at some point in time. But rice is just way too, I think it requires way too much water. And we see that where it was grown naturally or originally in China, or areas which are very unique in terms of their surface water resources. It's kind of it's an unusual kind of setting. This is what a rice paddy or rice field is called, a paddy. This is what it looks like. Rice is very labor intensive, especially in Eastern Asia. The individual plants are planted by hand. People go out and see photographs of this all the time. People going out and putting down the germinated rice plant into the field. That's remarkably labor intensive, but it is a very productive plant, and there's lots of rice. The other thing that you'll see in Southeast Asia a lot are these rice paddies are very much constructed. There's a lot of landscape terracing, field borders that have to be constructed to retain the water. It obviously has to be flat, and there's enormous energy outlays to grow this plant. They have a lot of people, so that makes it easier here. This is what foxtail millet and wild green millet looks like. Foxtail millet is on the right. The green is on the left. And you can see that these have these kind of shocks or heads, and there are lots and lots and lots of seeds in here. The seeds are not large. That's one of the reasons that millet is not as commonly used, but it certainly is used quite a bit. But they are productive plants. And again, all the big producers are grasses, and we see that again. I mean, if we didn't have grasses, we would not have probably domesticated plants that would be productive enough to fuel our societies here. Water caltrop and foxnut are these guys. They basically float in the rice paddies on the surface. There's sort of they probably were kind of riders to the whole rice domestication thing. These were plants that naturally grew in the wild state in the rice paddies, and so they were collected. The seeds were collected, and they were used. Again, but these are not productive enough to host whole civilizations on. That requires right. The water buffalo you see here are they're used for meat, they're used for milk, they're used for bird. Clearly domesticated from the local wild progenitor, dogs, and a different kind of animal, but very common and widely reared. You see them more in the south than you do the north. Pigs, this is kind of a classic. This is a photograph in the Philippines, a classic photograph showing pigs being fed in a trough and then coming in. Pigs are not necessarily the cleanest animals, and this kind of shows you those kind of the dynamics here. A lot of times these early agriculturalists kept their stock in their houses. In other words, one way to look at this is they turned their houses into corrals, and the animals would be kept there. One way to keep them safe from predators or from raiders is to keep them very close by. The downside of this is you're living the cheek and jowl with these animals. It doesn't take much to kind of visualize what the kids would have been doing. They've been on the ground playing, doing stuff, picking things up, sticking stuff in their mouth. There's a lot of sharing of bacteria and germs and diseases and that kind of thing. It's not an overly clean kind of environment. This is exactly how crossover diseases developed, and it is in these early agricultural societies where the first crossover diseases probably took place. There probably were major epidemics that are completely unrecorded. where half or so of a population could get wiped out because of these diseases. One of the better documented earlier diseases is the bubonic plague in Europe. It wasn't that came from what animal that came from? It wasn't that but it may have been plant. But anyway, but there, close to half of the population was wiped out, and obviously, what kind of people, healthcare systems they had would be incapable of handling that, and the population either has within it a sort of natural immunity, which is not shared by everybody, but it's present. And they either have that or they get eradicated. I mean, it's pretty harsh going. If you ever read descriptions of what Europe was like during the bubonic plague, it's pretty horrific. There were so many people dying, they were sticking out in the streets and their bodies were rotting. And I think I told you all the story about being in a doctor's office in England, realizing that a little canal in front of the doctor's office was chock full of bodies in the 1300s. Anyway, this is kind of a good visualization of exactly how that happens. There's not an understanding of spreading diseases through germs, or there's no real medical procedures that will protect you. You either have a genetic DNA defenses or you don't. And you probably in these early agricultural societies, you had multiple waves of diseases that are just not fully recorded or recorded in any fashion. But anyway, this is when it happened. This is why when Europeans get to the Western Hemisphere or to any kind of isolated island, Polynesian Islands, etc., although not as bad there, but certainly the Americas are the most extreme example. Whole populations were just wiped out. It wiped out quickly within weeks or months. The Native Americans came over in the Pleistocene before agriculture. They didn't have built-in immunities, as did people throughout Asia and Europe and Africa did. And so when Europeans came on the scene, they were harboring these diseases. Even if they were not symptomatic, they harbored these diseases in their bodies, and they introduced them. The death rates were just horrific, just unbelievable. Really quite stunning. And that was going on. In some ways, it's still going on, but the last really big outbreaks were the mid to late 1800s. So it was a 400-year plus process there. Anyway, so we look at the areas of domestication. You have northern China and the Wangho or the Yellow River Basin. This is where the millets were domesticated. In southern China, in the Yangtze River Basin, you had rice. That's where those were basically domesticated. And in the Yangtze Basin, there were actually two areas of early Neolithic sites where we can see this occurred. So these are the three areas, and each one of these areas has its unique plants and its unique context. Sorry, how did that happen? For how domestication occurred in these areas. In the Yangtze Basin, you have in the middle part, you have the Hopi Basin, which is in the middle Yangtze, and then you have the area in the lower, and this is in the northeast called Lake Taihu area, where there's also evidence of independent domestication in both of these areas. So this is what these look like. This is the northern area here, and then there's the Hopi Basin and the Lake Taihu area here near Shanghai. This red line here basically shows you the original distribution of wild rice, where it grows today. This was in the 20th century when this was mapped out, and it's quite a bit further south than these areas. But The early domestication occurred. Sorry. Oh, these are China. You're trying to pull them up, and Polynesia. Are they in there? Okay. Okay. You had me worried that I forgot to load these. Okay. And so what you can see here is the natural distribution of wild rice. It goes all the way into India, and a lot of people have thought for a long time that rice was independently developed or domesticated in India. It does not appear to be the case. But why there's a disjunction here between these two distributions is that in the early Middle Holocene, we strongly believe that this wild rice distribution extended much further north into the Yangtze River Basin because the temperatures were warmer. Middle Holocene temperatures, 7,000, 8,000 years ago. Things started to warm up about 8,000 years. By 7,000 years ago, they're quite a bit warmer. And these distributions of wild rice probably extended much further north into this area, but not all the way up into the Yangtze or the Yellow River Basin here. Didn't go up that far. This is quite a bit colder. Beijing is up here. It's quite a bit colder. This is still relatively moderately warm. And if we look at the distribution of these early sites, you can see their clusters, and each of these, here's Lake Tahoe, here are the clusters in these earlier ones. And these are just some of the major sites that I'll talk about. They're not all of them, but Peiling Gang is one we'll talk about. Chanrang Gong is another, and Pinto Shan is yet another. We'll get to these. But you see, these are basically all clustered in the eastern half of China. They're not further west. And this is where, in the Pleistocene, the more dense Upper Paleolithic populations would have been, and extended into the Mesolithic period as well. Here's some of the sites that we'll talk about. One of the reasons that we see rice being domesticated in the Yangtze River Basin is it has a very unique geological kind of pattern. And what happened here is that you had mountains that were being eroded in the far west, and then the river started draining to the Pacific Ocean. But in the late Pleistocene and the Holocene, this whole landscape tilted, and it tilted in a way that this area dropped and this area rose. Not so much that it caused an internal draining basin, but it flattened out this whole river valley, and so you have a whole series of lots of, this is only the major one, major numbers of natural lakes that occur here, because the drainage is just so bad. And you see this every time there's a major storm in this area. These areas flood like crazy, and there's just not enough drainage. And so you have this tectonic alteration of the landscape, and that happens, and it causes all sorts of problems in terms of drainage. But what it did here is that it also, these lakes were there, and then it warmed up, and the wild rice moved into this area, and these natural lakes were absolutely just perfect kinds of locations where this rice was growing naturally. And in these areas where you had high density populations, everything was set up perfectly for rice to be domesticated. Okay. So the couple of sites at Chanrangdong and Wandang, we have evidence as early as 9,200. So this is almost as early as the earliest evidence in Western Asia, and in all likelihood, with more work being done, they'll probably find sites that are equally as old. But we have here evidence of agricultural tools, and then a kind of botanical evidence. We don't actually have the preserved rice itself, but we have phytoliths, and phytoliths are silica bodies that form in grasses are very common, and rice has unique shapes in their phytoliths. Different grass families have different phytoliths, and you can identify those. And they have identified domestic rights vitalists in some of these two sites. And so the general consensus is that we're seeing here evidence of domestication, certainly is as old as 9,000 BC, and probably even older. That would be 11,000 BP years ago. And so these are some of the oldest sites with domestication there. There's a site in the Hopi Basin. It's quite a bit later, Pento Shan, where we have proper settled villages that have produced evidence of actual macrobotanical evidence of domestic rice. And one of the patterns that we see in these basins is we start to see group graves where people are being buried, and there are a lot of people being buried. This is one of the overriding patterns that you see in Eastern Asia, especially in China, is you start to see lots of graves with lots of people in the grave. And sometimes these appear to be sort of natural. Sometimes there are events there that clearly indicating elevated levels of warfare, and so you get a lot of information from these about the social relationships here, and lots of people is one of the things. This is just a photograph of the excavations at Wandang, and a lot of what you can see here is just people just doing digging in these alternating squares. But it's from this that you would recover the macrobotanical remains that you would use, that you would identify in flotation and give them to a specialist, a botanist specialist. In the Hopi Basin, can I get rid of this and move this? I don't know if this is, there we go. Side, this is just really frustrating. Anyway, so the Hopi Basin dwellings, what you see here is you'll see walls that have been built up, the internal hearths, you'll see doorways, you'll see post holes within these are kind of molded clay walls that you can see with posts put within them. So it's probably some sort of a wattle and daub kind of framework. And what that means, if you don't know what wattle and daub is you'll see fences made this way where you'll have a post sticking up. It's a fairly substantial, not hugely, but big enough not to miss. And then you'll take saplings and they'll weave the saplings between the posts, and that's known as wattle and daub. A lot of these early agricultural houses would use that as basically a core for a wall, and then pack mud on both sides to have more of an airtight, watertight kind of structure. Then you have thatch roofs on top of this, and this is what you can see here. And they're making kind of packed clay floors and packed clay kind of porches out here. You can see here, and this packed clay approach is something that really is very common in China throughout the prehistoric period. The ceramics that they make, and this, I don't have a good picture of ceramics, but the ceramics that they made, if you go to the San Antonio Museum of Art, they have some great Chinese ceramics there worth the seeing. Anyway, the ceramics that they made are very sophisticated. They're extremely well made. Lots of painting designs on them. Very well executed. There's really very little doubt that at some point in time here, these guys started to develop ceramic specialists, and this is people who were making ceramics all, I won't necessarily say full time, but consistently and a lot. And you see that in a lot of societies where individuals, men or women, will start to kind of specialize in ceramics and do that to a certain degree. I worked in an area in Africa, in Zambia, where there were 3 villages, and one of the village made all the metal tools for everybody, spears, knives, and all that kind of stuff. Another village made all the cooking ceramics, and then a third village made all the ceramic pipes, and they smoked quite a lot of dago, which is marijuana, and they made special pipes for them. And the pipe maker, who was an old guy at that point in time, really took pride in it. His pipes were outstanding. I've got a couple of my own, but he made really, really nice pipes that were highly valued and traded quite a bit. And that's another pattern that you see here, is you start to see evidence of trade, and where you see this quite frequently, not the only way, but you see it in the ceramics being traded from different communities to different communities. So the quality, this kind of gets back to Barbara Bender's idea, the quality of the materials becomes a valued item and a measure of wealth and surplus as you start making these really nice ceramic pieces, and they get traded pretty much in all the neighboring villages and valued in the neighboring villages. And they also are being found in these burials as well. In the lower Yangtze River Valley, say at Lake Tahoe, this is lower meaning downstream. You have a couple of sites, Bang and Homu-2. They're a little bit later in time, so these would be equivalent in time to Jarmo in the Middle East, site that we talked about there. And here you find well-preserved, because these houses get super saturated, and then they're basically dug out of water. And you find houses, wooden houses, made with very carefully put together mortise and pendant joints, and so the connections between the wood are basically little tongues of wood that go through, and then they're fixed with dowels. But you also find here wild and domestic rice, water and caltrop. You find dogs, which are domesticated in the Pleistocene, pigs and water buffalo. So there's a wide range of domesticates there. They're still collecting wild rice, but they have domestic rice, and they're raising dogs and cattle. And you start to see population concentrations at this point in time in a big way. And one of the things that was found here was quite a thick threshing floor in a area where they're removing the rice husk and hulls and stuff away from the seed. And this threshing floor, the remains just were packed in there, about 50 centimeters thick. So it's about this thick or so. So it's quite a large concentration, showing an intensive. This should be not poor, but lower. Anyway, spelling wasn't good there. But anyway, so they have a lot of evidence for more intensive domestication. This is just what some of the drawings of the mortise and tendon joint look like. And so these pieces fit into these slots. They'll go all the way through, and they'll be fixed to the dowel rod on the outside. But what you see here is really quality woodwork. And so again, what you're seeing is probably something where you're starting to move toward quasi full-time specialists, woodworkers, carpenters, ceramicists, et cetera, making really high quality working here. You see scapular spades, so the agricultural tools that are being used, and remember they're growing rice here, so you're in these muddy fields that are deep with water, and so you have to have something for dealing with all the mud and get the water in there. There's a chat here. Rats. Okay. I don't know what that's referring to, but rats. There we go. Anyway. And then at other sites, here's a site called Befudi, which dates from about 7,000 to about 6,000. And one of the things that you can see here is you start to find mass graves. And that's the whole mass grave pattern that you see in China is something that really stands out. Why these people are, it's possible that the communities are burying all their dead in these graves, but in other cases, it's clearly not a case. But you can see here that the bodies have been defleshed, the skulls have been placed in one area, the other long bones mostly in another area. So a complex pattern of burial. And it's reflective of the population densities we see. But once you get agriculture in Eastern Asia, the populations explode. You start finding lots and lots of sites. In northern China, the Huanghe or the Yellow River Valley, one of the earliest sites is Heiligang, dates to about 6,300 or so. And there we have evidence of domesticated foxtail millet, pigs, and dogs. And again, this is a colder area. so the pigs and the dogs can basically handle that. Foxtail millet as well. You get a period in the later Neolithic, the later domestication, called the Yangtze, which is a very famous period. Dates from about 4800 to about 3200 BC. And here you start to see large villages, and these are much larger than the early Neolithic sites are. You see the establishment of true cemeteries and this elaboration of painted ceramics again, and the ceramics are really quite remarkable from these sites. This is one of the Yangtze villages that was excavated, and you can see here that you have corrals here and a big open here in the middle, and then a whole ton of houses and habitation structures. One of these is extremely large. Maybe this was a chieftainship with a headman's house here, or a communal house of some sort or another. Outside, there's walls around this with gates. Here's a little gate here. You can't see the wall from here. You come in this way, that area was excavated. It banks up on the river, but this is some sort of defensive work, and you even have something that looks like a medieval turret there. But the animals would have been brought inside, the people living inside, major ceremonies, but the burials are on the outside, and there are large numbers of people being buried in these sites. And so these are fairly substantial communities. They're not unlike what some of the larger villages look like in Amazonia today. You know of any of the Brazilian rainforest, what the Native Americans like the Yanomamo and those people live in these huge villages. This is actually bigger than that. This is sort of a 3D reconstruction of what that might have looked like, with the river passing here and the houses in these open areas with corrals and meeting areas probably here. And here's this large hut there that stands out. Some other larger huts here. Exactly what the social organization is here is not entirely clear, but it's got to be something in the neighborhood of a tribal society, if not a true chieftainship, living in this area. Okay, just a drawing of what some of these Yangtze late Neolithic huts look like. A lot of these are what we call pit houses. The bottom, the floors are dug down under the surface, into the surface, and basically they have shortened walls or roofs on above the surface. One of the reasons for this is they're a lot warmer. If this is an area in northern China where it does get pretty damn cold, and you can build a house into the ground, and it's remarkably warm. I had a friend that lived up in Canyon, Texas, up in the Panhandle, and he built a house that was into the side of an arroyo there, and so he had one wall, basically windows, but three other walls that were into the earthen bank there, and this was back in the 90s, and it was an air conditioner and everything, and I talked to him, and he said, I might run my air conditioner 1 or 2 days a year, but you don't need it because it's so much cooler. And he said, and the heating is so much better as well because you're in the earth and it doesn't get anywhere near as cold. So if your exposed wall has insulation in it, it's quite a bit warmer than you might expect in the winter and quite a bit cooler in the summer. Now you might have a ceiling fan going or something, but not really running air conditioning. So these are a lot more comfortable houses than just building a house out on the surface. What some of the cemeteries look like, and what you can see here is that these are what we call bundle burials, and so these guys were defleshed. Their flesh was removed, their bones were collected, they were wrapped up, possibly put in some sort of a hide or a basket kind of container, and then all of their materials, and some of these have artifacts with them. All these things were buried kind of in a nice, neat little bundle here. A lot of care taken to the treatment of the dead here. A lot of careful, obviously loving care taken to this. Whether these represent, their ancestors or not, we don't really know. But a lot of attention paid to these individuals in a in a true caring kind of fashion. So these group burials in this context, these may represent different clans of individuals, so they have some sort of social organization within their villages that puts them into different groupings. But clearly a lot of care being taken. And why didn't that? There we go. If you look at, these guys have ceramics in the burials too. If you look at the ceramics, the Yangtze ceramics, the painting that is being done, you see that there are a number of motifs that should be totally foreign to y'all, because a lot of these are the same kinds of motifs that you see being painted today on Chinese ceramics. Yangtze are generally considered to be the foundation for Chinese civilization, although it wouldn't be classified as civilization at this stage of the game. But a lot of the motifs in the iconography that's being painted date all the way back to the Yangtze period. And you can go, I don't think they're open anymore. Is Pier 1 still open, or they closed? Did they go bankrupt? Yeah, but in the old days, you can go to any Pier 1, or you can now probably pick this up at an HEB, but just find some cheap Chinese ceramics, and you'll see these motifs still being painted in blues on a white background. It's incredibly common, and they still are used. Anyway, so the early agricultural patterns that we see in China, especially, are not shared in some of the other areas. One of the more interesting areas, if you get onto the island of New Guinea, this is in just north of Australia, there is a site called Cook that dates to about 7,000 BC. And here what we see is something entirely different. I know it's hard to make any sense out of this, but this is the excavation of an agricultural field. So this is all soil. And what they did here is they dug channels around these platforms. They didn't elevate the platforms, but they dug channels here to drain off water. This is an area that's incredibly wet, too wet. And so what they're trying there to increase productivity for their domestic crops is to drain the water away. A totally different situation in most areas of the world, but it's a totally different kind of placing. So you have, remember, this was an area about 26,000. You were finding grindstone tools where they were chopping down trees, and so the idea that they're manipulating their environment in a big way is not surprising. You also have, I'm getting ahead of myself here. This is going faster than I want. You also have domesticated animals, especially pigs. Pigs become a hugely important domesticated animal in island New Guinea, and they obviously have domesticated dogs. But these people end up growing pigs and using pigs in a whole variety of different ways. But here, these raised fields, as they're called, are a clear sign of early domestication. Okay, let's look at the South Pacific, and the South Pacific consists of, and we don't include Australia here. Remember, Australia was colonized at least by about 45,000 years ago, maybe 60,000 years ago, and it didn't really share in the cultural events that occurred in the South Pacific. And so you have the Micronesian Islands here that includes New Guinea, also the Solomon Islands in New Caledonia and Fiji here. You have Micronesian Islands that include Guam, the Mariana Islands, the Marshall Islands here, and then the more widespread and probably better known Polynesian Islands that include Samoa, Cook Islands, French Polynesia, New Zealand, Hawaii, Pitcairn Islands, and even Easter Island over in the far east here. The pattern of occupation at these sites is really interesting and quite unique. One of the ways that we've looked at this, that have been looked at, is looking at the native languages that are spoken on these islands. And so all of these languages are grouped into what are known as the Austronesian languages, and there are 4 subfamilies of these languages. 3 of these subfamilies are found in Taiwan. Taiwan, well, right now is a political hot potato because it was after World War II, Chiang Kai-shek and his group moved there. They basically still at war with mainland China, and this thing's heating up right now. But originally, it was not occupied uh, by groups that we would call Chinese. But we see early occupation in Taiwan during the Neolithic period, and it develops linguistically in quite unique ways. One of the 4 subfamilies is it's not in Taiwan, is quite widely spread. It's called the Malayan Polynesian language. You'll see it abbreviated as MP frequently. It consists of 2 subfamilies itself, the Western Malaysian Polynesian subfamily and the Central and the Eastern one. The Central Eastern Malayan Polynesian subfamily itself consists of itself of 4 subfamilies. 3 of these have very restricted distribution, but the one that's known as the Oceanic Malayo-Polynesian subfamily is very widespread. And the diversity in the languages give us a clue about how long these different areas were occupied and how much time that has occurred since they were occupied. If we look at a map of these, you can see the patterns. Here's Taiwan here. One of the original language families there was Formosan, which is still restricted there. The Western Malaysia-Polynesian families occur here from the Philippines, Borneo, all the way to Madagascar. And so these people migrated. These language families also give you a great tool for understanding what kind of migration patterns occurred here. So there are groups that came out of Taiwan, early Neolithic groups that came out of Taiwan that began to populate these islands. They went into the Philippines, they went to Sumatra, Java, all the way over to Madagascar. There are other islands here that they occupied. The Central Malaysian Polynesian groups are here in these islands here, just off the New Guinea coast. The Western, the Eastern Malaysian Polynesian groups. One group is here in a few islands, and I think this is Micronesia here, and then the Oceanic family spread all through Polynesia and Micronesia and Polynesia, and they occupied all of these families. One outlier here is in New Zealand, where that's one of these southwest Polynesian groups here. But if we look at this, you can get an idea of how these islands were colonized. Now we know that there were people on these islands, some of these islands, going back well into the Pleistocene. So these are some of the more recent colonizers that moved into these islands. The Micronesian Islands and Polynesian Islands were empty of people. Okay, there were no people there when these guys spread out. Okay, so how did this happen? And we're going to look at more details here. We'll look at the genetics. How did this happen? Well, the first thing that you had to have is you had to have some sort of watercraft that was ocean-going capable. And so these are not watercraft that you could float across 30 or 40 miles of open ocean on. These are serious open watercraft. And the watercraft that are there today probably go back in time. These are outriggers, and these are basically sailboats. Okay, they can be quite large. They can be very effective in moving groups of people, not huge groups of people, but groups of people. And because they're sailboats, they can take advantage of the wind currents in a big way. And they also could take advantage of the ocean currents in a big way. The other thing that you had to have, besides ocean capable watercraft, the other thing you had to have you had to have some kinds of domestic animals. When you get out on these islands, there often have almost no animals on them. There are very few animals on them, mostly rodent, small animals. In some cases, like in forests, the rodents evolved to become kind of giants, but in most of the cases they didn't. Many of these islands don't have any animals on them other than birds, naturally. And there wasn't, even though there's all the marine resources people could depend on, there weren't enough marine resources for these populations to survive there without having some sort of terrestrial backup system there. And so they brought domestic plants and animals with them. And then thirdly, what they had to have is they had to have a navigation system. There's no way in hell, I don't care how big of a boat you have, and I don't care how much you carry on it. Well, maybe the QE2 take years of food on that. But for the most part, these guys had to have a navigation system. They had to know, they had to be able to track where they were going, where they had been. You know, you go out into these, and we're talking about massively long ocean voyages of thousands of miles. You had to know how to get back home. You had to know, if you're going out, you're looking for islands, trying to discover new land. One of the reasons is you're running out of land at home. But you had to know how to get out where you're going, where you were going, but you also had to know how to get home. And that's what we see in the historic record here. So we find that Polynesian peoples developed star charts. Some of these are quite complex. Some of them also record ocean current, which are fairly stable. They change seasonally, but they're stable seasonally usually. And they record the location of islands, and roughly they're recording the location of distance. And so these guys were good sailors. They knew how to sail. They knew what they needed to do, and they knew with these star charts, they were in island charts. They knew where they were going. So you would use the stars for guidance, and they're not perfect for sure, but they were able to track where they were going to go to, and where they had been, and how to get back home, and basically how to find the water. You know, you're out in the ocean, and there's water everywhere, but you can't drink any of it, and you can't live for much over 3 days without water, if that. And so water was a critical resource here in a big, big way. Until you found land, and then you had to have domestic plants and animals to make that work. So this is a map of the wind charts that exist in the South Pacific, and these are quite variable. But what you can see here, so they're coming from Taiwan that is here, and they're moving out. So some of the earliest areas they moved into were the Philippines, Borneo, Sulawesi, and these other Malaysian islands here. And it's not a big surprise because that's where the winds were taking them. They then would go, the winds would take them east, coming out of New Guinea, and down to the southeast here as well. And they would be driven into these other areas. They could come back on they could get back into the trade winds here and come back on those winds as well. And then there are other islands and wind patterns here, getting you to other islands like Madagascar here. And so they knew the winds, they knew the currents. This is a map of the kind of average ocean current kinds of patterns. And again, you could use these to help propel you to the locations where you were trying to head here. One of the important patterns that plays into this is whether you have in the South Pacific you have variations in the wind and the ocean currents. These are called El Nino and La Nina patterns here, which they change the directions of the winds, and they affect the strength of the trades of the trade currents as well. And they almost certainly knew about these, and they knew that there were certain times when the winds and the currents would propel them further to the east, other times in the same areas that propel them to the west. And it's pretty clear that they took notice of this and were able to use this. So if we look at some of the most recent evidence we have for Polynesia, the occupation of Polynesia, comes from modern DNA, and we have mitochondrial DNA that's been measured in a lot of these populations. And what you can see here, one important thing is they don't really share mitochondrial DNA with Native Americans. There's a lot of folks that have hypothesized that there were large movements of Native Americans into Polynesia, especially, and that they were there's certain similarities, physical similarities between the two populations. And but when you start to look at the mitochondrial DNA, you see that the Polynesians have their own unique lineages that they seem to share, and they probably developed further east, and then they migrated to the extreme. So here up at I'm not sure if this is a Micronesian island here or not, but you can see that there's slowly these Polynesian lineages reduce in frequency as you move to the east, but if you move to the west, they don't exist at all. So it's pretty clear that there was not a major genetic input from the Americas into Polynesia, and there was a lot of local development. But it also shows you that these guys were coming from from East Asia to the islands here, which fits the language patterns remarkably well. This is a more detailed kind of breakdown with more islands, and you can see again that you have this pattern of these. This breaks it down into individual haplogroups. This one is the turquoise one is B5B/AS. I don't know what that means, but you can see that the frequency of that is here in Micronesia and Polynesia. Interestingly, when you get into to New Guinea, especially in the highlands of New Guinea, you don't see this hardly at all, and it's not common or it's not even present in Australia. Okay, so there's a very much of a social barrier when it gets to Australia. But they're moving all around Australia. They're coming in Australia, and maybe because the Australians wouldn't let them in. The Australians historically had been very protective, and they would kill strangers in a lot of these different groups. And so didn't want them there. But you see these guys moving all through Micronesia in a big way. And it shows the direct connections here. If the Y chromosome scale, we north in these cases, and show connections with East Asia as well, which again agrees with the mitochondrial DNA and agrees with the linguistic analysis. And we haven't even talked about theology yet. But it also is almost no interact further to the west with the Western Hemisphere Americans. If we look at the rate to about 5 BC or so in this example, these older dates are not particularly good estimates of the true age of these blue dates are better quality what you see there. And one of the things that you can see is that this is in New Zealand, is almost none of these things date back earlier than about 1000 AD. So we're seeing very recent occupations in the far eastern side of Asia, very recent indeed. And there's a hint at earlier dates, but there's some real debate about those. So if you plot it, look at these across space, what you can see is the dates, and there's some to the pattern in the linguistics. and in the archaeology, moving from mainland China to Taiwan about 5,000 years ago. In 3000 BC, they start moving into the Philippines, northern Philippines. As early as 2200 BC, by any stretch of the imagination. So here you see 100 BC, Madagascar, which is a hell of a long way away through open ocean. We don't see occupations there until AD 500. You see groups moving in here in Micronesia, and this area here in some of these smaller islands off the coast of mainland China. Here at about 1600 BC, 1000 BC. So they slowly start to spread out into Micronesia. You see people moving out about 200 BC, going into Melanesia about 1300 BC. So earlier here, they get out here, New Caledonia 1200, Tonga 900 BC, Samoa 800 BC. Then it slows down, and it slows down because the distances are so massive. And so you see people moving out into, say, the Society Islands in this area, about 80, 1,000. They don't get to until as late as 80, 1200. Easter Island, about the same time period. Also about the same time in New Zealand as well. They're earlier in the Chatham Islands, I believe. But so what you can see is this kind of step and slow process. And the reason it's slow is because they're going through thousands of miles of open ocean. And there are probably hundreds, if not thousands, of lost boats for these people that never made it and they couldn't get back home. But eventually some of these people did. So this spread is very slow. And one of the things that I'll say is that there's absolutely not a single shred of evidence to suggest that this was a migratory path that would have resulted in the migration and the initial colonization of the area. That was one of the pathways that was presented early on, and there's absolutely no evidence of that at all. That's just pure speculation. It's not even a good hypothesis. So it's so little evidence for it. Now the question is were there later connections with South America? And I think that the answer to that is probably yes. But anyway, let's talk about this. The earliest groups that we can archaeologically define groups that we can see moving into Melanesia are known as Lapita, and they became very widespread in Melanesia and Micronesia. And they had a very distinctive pottery with distinctive kind of impression designs on the pottery. But the earliest people that spread into the Pacific are known as Lapita. You need to know that now. And they were widespread on a lot of different islands. They subdivided into different subgroups, but in a general term, they were all known as Lapita. So the things that they needed to have here to make these movements into these islands workable is what they did have is they had pigs, they had chickens, they had dogs. So the animals they had were all small animals. They didn't bring cattle. They didn't bring any kind of large animal. They were all small animals, and they were animals that breed quickly for the most part. The dogs could be used for hunting and other things, but dogs also are eaten in Southeast Asia. In terms of the animals, you see taro and yams were domesticated. They obviously exploited fish purposes. Sea turtles, these were not domesticated. Sharks and shellfish, different kinds of nuts and coconuts, which are wild there. And so with all of these, and bananas as well, with all of these foods, they were able to survive in these areas. But you did need some domesticates. Later on, they domesticated. They brought in millets of certain plants, sugar cane, and rice. But initially, these things were not there. So if we look at one of the domesticated animals that we see in these areas is we see potatoes. And we know that potatoes were originally domesticated in South America. The earliest domesticated potatoes were in South America. And you can start to see and look at the varieties that occur mainly in Polynesia, and you can see the spread of potatoes probably relating to occupations from the Eastern Islands moving into South America. So there were connections there. They had gotten to South America. You don't really see much evidence in South America of this, but you do see the domesticated potatoes being grown and spread throughout Polynesia. And so there's no question that there was some sort of connection, without any doubt. But it was a minor connection, mainly probably related to trade and exchange, gesundheit, and it wasn't. You weren't talking about large numbers of people going back and forth, but there were connections. There definitely were connections. Okay, I'm going to end there. Any questions? Nope. Okay. Everybody have a good day.